All right, so this problem's all set up and ready to solve. Let me just grab kind of this circuit that we created here, the phasor domain, and move it over to the next slide. And we'll just go ahead and try and solve it. Let me throw this up in the top corner so it's not in our way. So the first thing I need to do is get rid of one of the sources. So let's get rid of the one on the right, and then we'll redraw the circuit. We're left with basically an impedance, another impedance, and then I'm going to go ahead and I'll draw it like this to start, but ultimately I hope you can recognize that now this resistor here and this inductor are now in parallel. So I could redraw this if I wanted to. I don't need to redraw it, actually. Let's just leave it alone. So it's going to be J20 pi, J60 pi, and 25 ohms. Those are my impedances. And again, I'm interested in this Vx value. We'll call it Vx1 for now, because we're going to eventually, for superposition, we know that Vx of t is ultimately going to be equal to Vx1 of t plus Vx2 of t. Okay, so we're going to go ahead and solve for Vx1 in this case. We know this is going to be 1 angle 0. And this is just going to be a simple voltage divider once we combine my inductor and my resistor here in parallel. So let's go ahead and do that. And we know that two guys in parallel are basically going to be, the equivalent impedance would be J60 pi times 25 ohms over basically 25 plus J60 pi. That's pretty straightforward. I'm just going to go ahead and throw this in my calculator at this point. I don't want to do all that math again, so that hopefully we all get to this point. For those of you who don't have the calculator or don't have any kind of resource available to you, I'm sure there's online calculators that can do this. So let me go ahead and do that. Just going to do the math, multiply by 25, and then I divide by 25 plus all right, 60 pi I. So I get that ZEQ is going to be 24.57 plus J 3.26. Okay, that's my equivalent impedance. And now I can just solve this voltage divider. So let me draw this just to clarify. I just combined these two impedances to create an equivalent impedance because these are in parallel. And so my new circuit just looks just like this, a basic voltage divider, right? And that's going to be J20 pi right here. And then this one is going to be 24.57 plus J 3.26. And I am after this voltage Vx1. Okay. So let's go ahead and throw my phasor value 1 angle 0 back here. And we can write out this expression. We know that, and I guess I called this one Vs1, right? We know that Vx1 is going to be equal to Vs1 multiplied by R2, or in this case it's going to be Z2. I'll just call this Z1. You know, that was ZL1, and this is my Z equivalent. So it's going to be Z equivalent over Z equivalent plus ZL1. That would be my voltage divider equation. So that's going to come out to 1 angle 0 multiplied by the equivalent impedance, which I just calculated, divided by that same impedance, plus J 3.26, but plus another J 20 pi, okay? And so I'm going to go ahead and compute this in my calculator. Divide by this plus 20 times pi times I. Sorry, this is going to take me a sec just to make sure I have my parentheses right. Yep, that looks good. So Go ahead and compute it. And I get, for this entire term here, I get 0.165 minus J 0.310, okay? And so now I can convert this to a phasor so that I can multiply it by my 1 angle 0, and then I can get my value for Vx1. So let's do that. We know that for a phasor, it's basically going to be R is equal to the square root of 0.165 squared plus 0.310 squared. That's going to give me, let's see, 0.165, 0.310, and I just add those. I get 0.123. Nice. Okay, and then my angle is going to be tan inverse of negative 0.310 divided by 0.165. Let's see what that comes out to. Negative 0.310 divided by 0.165. Oh, I'm in the wrong mode here. Let's go back to degrees. Okay, so I get phi is equal to negative 61.97 degrees. Okay, so I'm left with Vx1 is equal to Vs1, which is 1 angle 0, multiplied by 0.123 angle negative 61.97 degrees. If you remember correctly, all I have to do to multiply two phasors is multiply their magnitudes and then add their phases. Okay, so let's do that. And my value for Vx1 is going to be 0.123, because it's 1 times 0.23. Angle 0 plus negative 61.97 is just going to give me negative 61.97 degrees. And that is my value for Vx1. Okay, so we got Vx1 here. We could convert it to time, but I'm just going to leave it in phasor for now. And then in the next video, I'm going to go ahead and do the second circuit, which is basically this exact same process, but we need to get Vx2. So I'm going to go ahead and end this video here, and we'll see you in the next video.